Hello, guys. Welcome back to Math Zone African Motives. This is still our integration. Still working with the integration question papers, and this is August 2021 exam. We just want to see how exactly are we supposed to work out these typical questions. It's very, very important that you understand your basics, all right? You understand your basics, like each and every integral has got its own way if you are dealing with these integrals. Talk of the trigonometric, the inverse, whatever that you're given. All right. So there we are given question number 2. Determine the integral of y with respect to x. If 2.1, we are given this here, and that is 2 marks. All right, 2 marks. Why 2 marks? Why is it like it's too little? Okay, let me just rewrite this so that we can properly see. We're given to integrate in bracket. This is 1 plus 10 squared. So we put 1 plus 10 squared, 3x in a bracket. And this is another bracket. We have got sec squared, 3x minus 1 like this. So this is with respect to x. So if you check, they are trying to hide something here for us. If we check on the integral of tan, we talked about the integral of a tan. It can be a tan to the exponent of n, ax with respect to x, or it can be of a cot to the exponent of n, ax with respect to x. These are the integrals that we expect. And of these integrals, we are going to use the appropriate trigonometry, which our identity that is appropriate to any of those identities. But now they are hiding this for us. This is what they are trying to do. Why am I saying this? They are hiding this because we understand that, okay, let us take this identity for tan. We understand that tan squared x, so there I'm going to write in terms of 3x. So tan squared 3x plus 1 is equal to sec squared 3x. This is what we know, okay? So the question is, whenever we see 1 plus tan squared 3x, or wherever we see tan squared, we get sec squared. All right, this is what we see. And if I have a sec squared minus 1, if I transpose this, guys, if I transpose 1 that side, it means I'm going to remain with this. Tan squared 3x is equal to sec squared 3x minus 1. So if I see this sec squared 3x, I see tan squared 3x. If I see 1 plus tan squared 3x, what do I see? Sec squared 3x. That is exactly what is there. So you see, they're trying to play like a movie, like something to us. It's a play around. Because this here, we simply get it back. They are simply playing around. This is not of this nature. No, don't think about that nature at all. It's not even there. All right? So this is going to be taken back. 1 plus tan squared, it gives us sec squared. So this will be the integral of sec squared 3x times sec squared minus 1. Sec squared 3x minus 1, it gives us what? Tan. So this will be a tan squared. So we are going to have tan squared 3x with respect to x. This is where we are. We just rewrote this in another way around. This is what we have here. So let us think along this. Can this be integrated or not? Do we have to introduce a certain identity or not? Okay. If we can think of the substitution, tan can cancel sec squared because the derivative of a tan gives us sec squared. So we can think of the substitution method. So on this one, we can use substitution method. So there, let us think of the substitution from our N5. All right, so if we let u to be equal to tan, remember the derivative of tan, it's sec squared. So it can cancel with this one. If you choose your u to be sec squared, it is going to be sec tan. It can't cancel this because this is tan squared, all right? So you choose u so that it can cancel what you have here. So our u, let it be what? The tan of 3x. so that the derivative of u with respect to x is going to give us 3. If the 3 multiplies here the number, so it's going to be 3. Remember, tan changes to sec squared 3x. Then we make dx the subject. So if we make dx the subject, if we cross multiply this and that, it is going to be du over 3 sec squared 3x like this. Okay, this is what you're going to get. Meaning to say, you are going to substitute back here like this. You're going to have this as the integral of sec squared was going to cancel with this sec squared 3x. All right, let me just rewrite what we are supposed to do, because I think when I'm doing this, I'm always confusing you guys. Let me just do it stage by stage. You're supposed to have sec squared 3x like this times tan squared 3x like this times dx. Your dx is this part of du. So it is du over 3 sec squared 3x. So this is what I'm trying to say when I'm saying you cancel this and this will cancel. In the numerator, this is in the denominator. So we remain with 1 over 3, that is a number, and this number can be taken out of the integral. So it's going to be a third, the integral of tan squared. Why am I writing tan? The tan here is already a u, all right? So this, let us write u squared, since we are having a u here. So the derivative of a u with respect to u, it can be derivative. We can integrate, the integral. So we integrate u with respect to u. So this is u squared. We add a 1 if we integrate. So here there's no need for me to write the integral sign, because already, or let us just write so that we show that is what you're going to remain with at the end. Because we have cancelled this, we've taken the 1 over 3 out of the integral sign. So let us integrate. If we integrate u squared, we are going to add 1. That will be u to the exponent of 3. We divide by the new exponent. Remember the concept of our integral. So if we multiply 1 over 3 and 1 over 3, this is the same as 1 over 3. So 1 over 3 times 1 over 3, that will be 1 over 9. Then u is represented by what? By tan. So it is going to be tan to the exponent of 3x. This is tan plus the constant of what? Plus the constant of integration. So that is what you're going to have in your last stage of your calculation. There's nothing that you can do further. So that is how we're supposed to get this one. It was just a mere substitution. This one is just direct sec squared. This one is just direct tan squared. Use your substitution, you're done. Just like that, all right? Let us check 2.2. On 2.2, we are given, again, integrate. This is arc sine, all right? So we are given 2.2 to integrate arc sine bx. So this is arc sine bx with respect to x. So this is, we are dealing with an inverse trigonometric function, an inverse. So for this type of an inverse, you use what we call by parts. How do you apply by parts? Remember that by parts states that the integral of f of x by the first derivative of gx, g prime x like this is equal to f of x by gx. All right, so it's f of x by gx minus the integral, this time of f prime x gx dx like this. So on this formula, it states that we are supposed to have f of x and g prime x. But here we do not have, we just have a single term, which is an inverse trig. So how do we write this way so that we can have two terms? Because I'm saying you're supposed to use by parts. All right, this here is the same as the integral of 1 times arc sine. So you introduce 1, just like that integral that we did in N5. It was the integral of ln, all right, where we said ln is 1 times the ln of x dx. What we just want is to have two terms where we can consider 1 to be our f of x, and we can't choose our f of x to be a 1, because if we choose that, the derivative of a 1 is a 0. So our f of x is going to be the part of this inverse function that we are given, inverse trig, this one. So this part of arc sine bx is going to be our f of x. So we are going to choose this to be our f of x. So if I choose this to be f of x, what does it mean? All right, if we choose our f of x to be arc sine of bx, therefore 1 dx is the one that is representing what? This part of g prime x dx that is remaining. So that means g prime x dx is the remaining part, which is 1 dx. So this is 1 dx, right? So on this part, what is it that I need from f of x? I need its derivative, the first derivative of f of x. So what is the first derivative of f of x from x sine bx? It's unfortunate that I actually forgot to insert the formula sheet. But I'm going to explain this from your formula sheet so that you understand. If you check on your formula sheet on the derivatives on page number 3, right? I want you to check on page number 3 on the derivatives, all right? On page number 3 there, you see on arc sine, on the derivative of arc sine, it's written like this. Arc sine f of x is equal to the first derivative of f of x. So this represents the derivative with respect to x of arc sine. All right. So is the first derivative of f of x over the square root of 1 minus f of x squared. All right. So I'm explaining this so that you also understand your formula sheet. F of x squared like this. This is the formula for the derivative of an arc sine. So meaning to say, this is our arc sine, this is our f of x, this part of bx here. The bx represents our f of x. So when they are saying the first derivative, it means the derivative of bx, which is what? Which is b over what? The square root of 1 minus f of x squared. So it's 1 minus our f of x, which is this function, or as it is. So it's bx as it is, like this, is squared like this. Of which this, we can write it, we can square each and every part. It simply means we've got b over the square root of 1 minus b squared x squared from our exponents, all right? N3, we raise this to the exponent of 2. That was our N3 stuff. So we raise this to the exponent of 2, everything, all right? So that is, we applied the formula from our formula sheet, like I said, from your page 3. I want you to check that formula. So this is how you could have differentiated your arc sine. But back on this side, what do we need? We need the integral from gx, all right? Because here, they are, from g prime x, so that we obtain gx, we are supposed to integrate so that we obtain gx both sides. So integrate your gx, you're going to get gx. Integrate 1 with respect to x, this will be x. Yes, we know we're going to have the constant, which is fine, but we still are integrating, so don't worry about that. So now that we have got these, let's get back to the formula so that we find the answer to this integral that we, so this whole integral here, this whole integral of arc sine, whatever that we're given of bx is going to give us what? All right, so from the formula, this whole integral is going to be equal to, so these were just calculations that were made. So these are just calculations that we're just making here. All right. So, okay. So now I'm writing the answer here. So this is, all this integral is equal to f of x by gx. F of x is arc sine. So this is arc sine bx. All right, times gx, we got x. So this is x, all right, minus the integral of, so you're going to have the integral of the first derivative of f of x, and this is the first derivative of f of x, which is b over the square root of 1 minus b squared x squared like this, times what are you going to multiply? Gx dx. So this is our gx, which is x. So it's going to be x dx like this. All right. This is where we are. So we simply took this from the whole integral of arc sine dx that we had. All right. So I'm just going to write here arc sine dx. So that is the integral of what? Of arc sine bx with respect to x. All right. Now at this stage, we can see that there's something that we need to be simplified and integrated. Here we can just multiply by x. So it's going to be x arc sine bx, all right, which is this way, minus, we can multiply this, or we can take b out of the integral, it's fine, or we can multiply b times x, which is going to be x was the same as over 1. So this is going to be bx like this over the square root of, so this will be the square root of 1 minus b squared x squared. So everything is under the square root. Then we have to integrate this with respect to x. So now at that stage, the by parts, like I always say, is even from our N5, this is your by parts. It played a role here to use this format, this formula here, differentiate, integrate this. At this stage, it has ended. It is now you and your understanding of your integrals to say, which integral are you supposed to use? Are you supposed to use by parts again? Is it applicable? Are you supposed to use substitution? Are you supposed to, what are you supposed to use? It's now in your hands. So I want you to be very, very careful on that one. So if we check properly, there a substitution can work because there's something familiar about this. 1 minus b squared x squared. Then we also have a bx. So let us try to have a substitution there. What can we do? Let us make this to be the subject, to be our u, all right? So we're going to integrate by substitution this part here, all right? So I'm just going to let my u, all right? Let me do this. I'm just going to let my u to be equal to 1 minus b squared x squared. All right, this can make sense. So the derivative of u with respect to x. So take note, guys, from your partial derivatives. We talked about this where you are differentiating with respect to x. So it means b is a constant, all right? Just like 1, the derivative of 1 is 0, but this is b part of x squared. So you ignore the minus b, you differentiate x squared. The minus b squared is a constant, it's just like minus 2. If here there was a minus 2x squared, how do you differentiate? You ignore this minus 2, you differentiate x squared, you get 2x. Whatever that you get, you multiply to that 2. So that is the idea that you're simply, because b is a constant. So if you differentiate, this will be 2x. So meaning to say, here we are going to have minus 2b squared x like this. All right. So from there, this is our derivative of u with respect to x. All right. It was u and x. So the derivative of u with respect to x, which is equal to this. So what I want you to do is to make dx the subject, because we have to substitute this, we have to remove it. So if you make dx the subject, this will give you a du over minus 2b squared x, of which you can take this negative on top so that it will be minus there on top. It's one and the same thing, guys. Don't panic, okay? It's one and the same thing. So the purpose here is that whatever that we get here, we are supposed to substitute back in where there is what? Where there is our integral. All right. So that is the whole procedure that you're supposed to do. All right. So I'm just gonna focus on where we are. The rest of the part, I'm just gonna ignore it. All right. So this is going to remain as it is. The first part, x times arcsine of bx minus the integral. So this was supposed to be written like this: bx over the square root of, remember we said 1 minus b squared, the whole of this part of 1 minus b squared x squared, it represents what? U. So it is going to be the square root of u. All right, times dx. We substitute now dx with what we got here, which is du over negative 2b squared x like this. So this is what we are now keeping our eye on so that we can be able to integrate. So the first part, as like I said, it's just going to remain as it is. So it's arcsine of bx here. If we check here, there is a 1 over minus 2 here, but here there's a b. So the b and the b squared, this will give us a b. So we can take 1 over minus 2b outside, but already there's a negative there. So it will be negative, negative, which is a positive. So it will be 1 over 2b. The 2b is in the denominator, so it will be written like this: 1 over 2b, the integral of, why am I taking b outside? B, remember, it's a constant. It's just like a number. It's like a 2, like a 3. It's not x, so you take it out of the integral, all right? Then what you remain with is 1 over the square root of u, which is same as u to the exponent of minus half. Remember, 1 over is to the exponent of a negative. The square root means to the exponent of a half, but the 1 over is to the exponent of what? Of a negative. So you differentiate this with respect to what? With respect to u this time. All right. So that is the idea of our question in this case. Remember what happened on B and B. Someone is asking, what about X? X and X cancels. This is X, this is X. It cancels. It's no longer there. All right. It's no longer there. It is the same. So it's no longer there. We're just left with 1 over the square root of u. This negative here and this is the one that gave us a positive. So it's no longer there also. This 2b is the one that we wrote outside of the integral, 1 over 2b. So inside, you're just left with 1 over the square root of u. But 1 over the square root from our exponents, it means to the exponent of a negative half. So that we can properly integrate with respect to what? With respect to u. All right. So that is the idea of our question. So let us integrate here. What are we going to get if we integrate? The first part, like I said, here we're just rewriting as it is. All right, sorry for that. So this is x sine of bx like this, all right, plus 1 over 2b. If we are to integrate this, I'm just going to do this aside here. If we integrate, remember we add a 1 on top here. So it is going to be, if we add a 1 minus a half plus a 1, it is going to give us a half. So it's over a half, which is the new exponent that we are given. But 1 over a half is a 2. If we divide 1 divided by a half, it's a 2. So it's 2u to the exponent of a half. And we all know that to the exponent of a half means the square root. So it was going to be 2 square root of u. And we all know that the square root or the u that we are talking about is this one that we said u is. So it is going to be the square root of 1 minus u, which is which is u, which is 1 minus b squared x squared. So now we have to write this as 2. So we're gonna so there's no need for me to write this bigger bracket because already. So what I did, I integrated this aside. All right, we got this from the substitution part. All right, we just have to take back our u and substitute back. So after integrating this whole part, we are obtaining 2 the square root of 1 minus b squared x squared like this. So this is the whole integral plus the constant of integration. So we just have to simplify what can be simplified like this part, the 2 and the 2 can cancel, all right? And also if we check this b squared x squared that we see here is the same as this part here. Where is it? Here. When it was written as, okay, where is it? Here. I want you to see something. Where did I take this one from? Okay, I think I erased or what happened. Oh, it was here on top maybe, yeah. Okay, here. This b squared x squared that we see, it was taken from what? From bx squared. So you can write it like that, bx squared in a bracket, or you can even write it separately like this, it's fine. So let us write our final answer. Let us just finalize our answer. So this will be equal to x sine bx like this, plus, so like I said, this and this cancel, so you are left with 1 over b. So it is going to be 1 over b, the square root of 1 minus, like I said, you can leave it like b squared x squared, or you can write it as bx squared like this on your final answer. It's just 1 and the same thing. So that is going to be our integral at the end. This is what you're supposed to get at the end. So if you check, it was a nice question actually, but we have to consider a lot of things inside. One, that is the application of your bypass by letting your f of x to be arcsine and your g prime x to be 1. After that, you apply your bypass method. So this was the application of bypass from here. We are substituting in the formula here. So this was the substitution of the bypass formula. So like I said, whatever that happens after this, after you've simplified, you are now at this stage, you simplify again to whatever stage that you want. Whatever that is going to happen, like what we had here, it's in your hands. Are you going to apply bypass again? Is it substitution method? What method are you going to? Sometimes you obtain something that is direct, u squared, maybe x cubed with respect to x, something that direct, you just integrate when it is like that. But here it was not direct. We have to apply substitution method. So here it was this part now of the substitution method in order for us to integrate this. We are now applying what? A certain method. So this is how your questions are going to be like. You combine one method on another, you take another to another, and like that, you can be able to integrate and simplify further. All right, so that was our question. Let us go back to our questions and see what is following them. That is 2.3. All right, so 2.3, we have got a square root. There is just a square root. So that is, they are saying we are supposed to integrate the square root of 6x minus x squared like this with respect to x. All right, how can we do this? How can we integrate this? All right, remember, once you are given the square root and you are given an algebraic expression, all right, this quadratic expression, we are supposed to think of what? Completing of the square method. So here we are supposed to think of what? Completing of the square, completing the square. All right, so how so? Remember I said on the completing of the square method from our N3, we can use the traditional method that we are used to, or we can use the formula. So this is 6x minus x squared. If we were to use the traditional method of our completing of the square method, we have to make sure that this is a positive. So this was the same as, or let us write it aside here. This is the same as we've got minus x squared plus a 6x as it is, just starting with what? X squared. So what we want is to make sure that this is a positive, the coefficient of x squared. So how can we make the coefficient of x squared without changing our expression, without changing our way of presentation? We factor out a negative. You don't divide. You only divide if this is an equation, but for an expression, you factor out the negative. So it will be negative, negative, which will be positive x squared, and positive, negative, which will be negative 6x. So this is what you obtain. Then remember, from your completing of the square method, you need half of the coefficient of x, half of the coefficient of x, which is the coefficient of x there is negative 6. So we are going to need half the coefficient of negative 6 squared. All right, half the coefficient of negative 6 squared. Half of negative 6 is negative 3. So we've got negative 3 squared, which we are supposed to add and also subtract on our expression. Remember, guys, you're completing of the square method. Do not forget that part. We are supposed to add the square and we subtract the square. So it will be x squared minus 6x like this. We add our square, which is minus 3 squared. Since we do not have a number here like a 5, a 7 that is added, you just subtract your square as it is. So you're just going to subtract your minus 3 squared as it is. All right. So at this stage, we have formulated a quadratic expression, which is a perfect square, this part here. We have a perfect square from this x squared here up to this x to the exponent of 3. It's a perfect square expression that we have formed, and you can see that it's a quadratic expression that we are used to, that we can be able to factorize. So what you do is that you are supposed to factorize this quadratic expression. So how do you factorize? You take the first term, which is being raised to the exponent of 2, and the last, first and last. So it's going to be the first, which is x, combined with the last, which is minus 3, everything squared. You have factorized this. You're done. You have factorized this. Then the rest you're going to simplify. So it's minus 3 squared, it's 9. So it's going to be minus 9. Yes, we can expand the bracket by minus. Minus times the bracket is going to be minus into the bracket of x minus 3 squared. Minus times minus 9, which is going to be a positive 9. So you can start with a positive. You can leave it like this, or we can start with a positive. Let us just start the positive. We do not know what's going to happen later on our on the formula to use. So you can just start writing this with a positive as long we know what it means from this part. So this is x minus 3 squared. All right. So this was the application of the traditional method, like how exactly we're supposed to use our completing of the square. But like I said, we can also use the formula for us to complete the square. There is a formula that we can actually use as long our expression is written in the form of ax squared of the quadratic. Remember your quadratic expression, ax squared plus bx plus c, like this. And there we have got our quadratic expression, which is minus x squared. After rewriting this, we have got minus x squared plus 6x. This is what we just have. Not factorized, not what, as it was, minus x squared plus 6x. It means we do not have the constant. The constant is what? It's a 0. C, it's a 0, like that part. Here it's our a, which is minus 1, b, which is 6, c is a 0. So the formula states that if we have a formula in the form of ax squared plus bx plus c, like that, we can complete the square if this is going to be written as, 4ac minus b squared. So this is 4ac minus b squared over 4a. So everything over 4a plus a into the bracket of x plus b over 2a, like this, everything squared. So it's x plus b over 2a, everything squared. This is how you can complete the square, where you are simply substituting your a. From this format, our a is what? The coefficient of x squared, which is minus 1. So it's 4 times minus 1 times c. Our c is a 0 on that one. Minus b squared, b, which is 6. So it's going to be 6 squared over 4 times a, which is minus 1, like this. All right, plus a is minus 1. So it's minus 1 into the bracket of x plus b, our b, which is 6 over 2 times a, which is minus 1. So if this formula is true, it means we must obtain the same answer. That is the idea. If this formula is true, it means we are supposed to have the same answer, like the traditional method of our completing of the square. All right, so there we're just gonna need our calculator for the first simplification. Put a fraction here, that's 4 times -1, 4 times -1, sorry, times a 0. Okay, any number times a 0, guys, is 0. All right, so here there's no need for us to write all this. So this is simply 0 minus 6 squared. 0 minus 6 squared over 4 times -1, like this, which is going to give us 9. So we are going to get 9. Plus and minus, we get a minus. So it's going to be minus. We simplify this. So this is going to be x. Plus or minus, we get a minus. So 6 divided by 2, that will be a 3 squared, like this. All right, is it the same answer that we had previously by using our traditional way of factorization, completing of the square? This is exactly what we got. 9 into x, 9 minus x minus 3 squared. So after you've completed the square, whether you choose to work with this formula, so this is from the formula, you have the formula, you are supposed to know your formula. So after you've determined this, you are supposed to come back now and determine the integral of the person that you're given. You're asked to integrate here, we are asked to integrate 6x squared minus the square root of 6x minus x squared. So we are going to have this as the integral of the square root of what is it that we obtained. We obtained this expression at that stage. So we write what we obtained, which is what? 9, the square root of 9 minus x minus 3 squared. This is what we obtained with respect to x. That's it. So this whole part of completing the square was just there to guide us, but the whole part here, or the whole concept of the person is for us to to integrate this after the application of our completing of the square method. Can we be able to integrate? And I told you, whenever you're dealing with this type, we are supposed to use the formula. There's a formula that we are supposed to have, and that formula is, there's only one formula that suits our integral. So I'm going to show you the formulas from our formula sheet. Let's hope I inserted this part of the formulas. If not, let me try to insert. Very sorry for that, guys. Let me just try to insert our formula sheet. I want you to properly see what I am explaining so that it will be like I'm explaining something else. All right. Let's check. Let's check. I think it's gonna be fast enough. Page 4. It's supposed to be page 4. All right. There we are here. So if you check on your formula sheet on page number 4, there are these integrals, and I talked about this before. These integrals here, they help you to integrate whenever you are working with completing of the square method. One of the answers is going to be taken from these integrals up to the last one, or where we start applications of integration here up to the last one. So there's only one formula, there's only one part that can be written exactly the way our integrals will be given. There's only one that is going to be given. So it must match exactly the way it is given there. What am I trying to say? Remember our question now, we are at a stage, all right, let us get back to the person. We are at a stage where we are supposed to integrate the square root of 9 minus this. All right, I'm just going to write it again so that we properly check our formula together. We are at a stage where we are supposed to integrate the square root of 9 minus the bracket of x minus 3 squared. This is the stage where we are. So which of these is going to match exactly the way we are given here? All right, is it the first one? No, this is a fraction, 1 over. We do not have a fraction, so this is totally out. Is it the second one? No, we do not have a square root already. It's a fraction, do not have square root. Is it the third one? All right, the square root of a squared minus, this is the greatest possibility that we can have. It can be written this way: the square root of a number squared and a number, another part squared. So this is the best. The second one is totally out. The third one, x squared, this one is start with x squared, unless we have to change this part, it's actually out, this one, right? So this one is out. Then another one, this one is out, 1 over the square root of this is totally out. So meaning to say, the best formula to apply was this one. It matches exactly the way that we have here. So I'm going to rewrite this formula so that we also try to use it together properly. All right. So on this formula, we saw that the integral of, from the integral of a squared, the integral of the square root, it was under the square root, right? Under the square root of a squared minus b squared is given there with a sign as it is, minus b squared x squared. With respect to x is going to give us x over, so this is the formula. That was, okay, sorry guys, I'm mixing a lot of things, sorry for that. That was a squared over 2b. Okay, check on page 4, on page 4, guys. All right, arc sine dx over a, all right, plus x over 2, the square root of, I'm just taking the formula as it was, all right? So it's gonna be the square root of a squared minus b squared x squared, like this, plus the constant of integral. This is the formula that we are supposed to use. Okay. So the question is, are we able to have this in this same way? Yes, it's possible. Because if we consider this, 9 is the same as, in this way, is the same as 3 squared, the square root of 9, which is the same as square root of 3 squared. So this is same as 3 squared. Minus, do we have a b squared? If the number is not there, if we do not have that term, it's b, because b is a constant, you write as a 1. So it's 1 squared. All right. X squared, x is this bracket where there is x. So it's the bracket of x minus 3 squared as it is, like that. So meaning to say here, this 3 represents a, just like a squared. B is represented by 1, just like this part of b squared. The part of x squared is represented by what? By x. So this is our a, this is our b, this is our x, just like this part. So that if you write it in this way, you properly substitute, because this one is just a substitute. There's nothing new that you are working here. You are not formulating this. It's not your formula. This you are given. You are just substituting a squared over 2b. What is our a squared? We are substituting now. Our A is 3. So it means 3 squared. 3 squared gives us what? 9 over 2b. What is our b? Our b is 1. So it's going to be 2 times 1, which is 2b. All right. Arcsine. So this is going to be arcsine bx over a. What is our bx in that case? B is 1. So it's going to be 1 times x. X is represented by the whole bracket of x minus 3. It represents your x. All right. Everything over a, and our a here is 3. So this is what you're going to have, plus x over 2. Wherever there is x, our x is represented by what? X minus 3. So it's going to be plus x minus 3 like this over 2. The square root of, if we check here properly, a squared minus b squared x squared. This part here is the same part as what we had before. We just rewrote in a way that we understand, but it is the same thing. This one here and this is the same format, but we just rewrote in this format so that we can apply it this way because we understand if it is written this way. So when you substitute here, you are simply substituting this part of what? This part that we had before. So it is going to be the square root of 9 minus the bracket of x minus 3 squared instead. All right. So then plus the constant of what? Integration. So that's it. We can simplify where it needs to be simplified. This here is same as 9 over 2. 2 times 1 is a 2. So it's 9 over 2 times 1 over 3. This here is same as we've got. All right. So this is arcsine. It's a single term here. Just leave it like that. Just simplify this one. 9 over 2 as it is here. Then this is arcsine. It's a single term. So it's arcsine of 1 times x minus 3, which is simply x minus 3 over 3 like this. Just leave it like that. It has no access to this. It cannot be multiplied, right? The rest remains as it is. It's already in simplest form. X minus 3 over 2. The square root of 9 minus x minus 3 squared. Like this. Plus the constant of what? Of our integration. This is what you were supposed to have at the end of your simplification. So it's either, if you want, you're going to expand the brackets, but guys, this is not necessary. At this stage, it's enough. But if you want, you can expand the brackets, collect like terms, you see whatever that you're going to get there. Guys, this one is your choice if you want to do that. But at this stage, we are done. It was just your normal by parts. Your normal use of the completing of the square method, sorry. So from the application of the completing of the square method, we have to complete the square from the quadratic expression that we are given, but not forgetting the properties that are there. It's under the square root. So it maintains whatever that you get under the square root. Then we can integrate using one of the appropriate formulas from those formulas that I showed you. There's only one that is going to be appropriate for that integral that you be given under an exam condition. So you've just revised more questions so that you see typical questions on how they can ask those questions. Like you just have to understand also as an individual, how do they ask? So the more we do the questions, the more we understand how do they ask some specific questions in our final exam. If we check 2.4, it's a cos, the integral of a cos. All right, and okay, this one, let's save it. Let's just talk about this. We had a similar question of this nature, cos to the exponent of 4. This is 3 over 2x, like this. Okay, this is what we're given with respect to x. So how do we integrate a cos? A cos and a sine, when they are being raised to the exponent of a 4, which is an even number, when they are raised to the exponent of an even number, they follow their own stages, which is different from a chord. All right, whenever they carry an even exponent like this, we expand using these identities. The sine squared of ax is equal to a half minus a half of cos 2ax. For a cos, it is going to be cos squared of ax, which is equal to a half plus a half of cos 2ax whenever they are even exponents, and we expand the even exponent, okay? If they are odd exponent, we use the identity of sine squared ax plus cos squared ax is equal to 1. Then we manipulate according to the one that you're supposed to use for that formula. So since here we are working with the cos, we are going to just remain with this identity of a cos. So meaning, in order for you to expand this, we are expanding, wanting to have what? Cos squared. This is what you want to have. So it is going to be the integral of a cos squared of this 3 over 2x like this, all right? Then we square it like this because we've got a cos squared. But for us to obtain a cos to the exponent of 4, we have to square this, all right? So we are going to square this, all right, with respect to x. But if it was a tan, you do not square. A tan to the exponent of 4x is separated as tan squared x times tan squared x. You don't square like this, all right? This is only for a cos and a sine. That's where you square it like that, okay? So this is what you're going to have. The integral of, we are now substituting what is equivalent to cos squared, which is this part. So it is 1 over 2. So we've got 1 over 2 plus 1 over 2. This is 2ax. So it's 2 times ax. Our ax is the one that we have on cos squared, which is this one. This is our ax on cos squared, this one, which is 3 over 2x, this one. So we have to multiply that by 2. We multiply by 2, this and this cancels. We get 3x. So we are going to be left with cos 3x after multiplying this by what? By 2. So this will be cos 3x. It's no longer cos 3 over 2x. It has changed. But this whole part has to be raised to the exponent of 2. We have to square it. Then we integrate with respect to x. So the identity, that's where we use it. Okay? Just like that. So now, since we've got the x, whatever that you have to the exponent of 2, remember the brackets of a plus b squared from our n3 and n3, n2 and 3. It gives us a squared plus 2ab plus b squared plus 2ab plus b squared. So meaning to say we have got the first term and the last term here, which is this one, as our a, and this as our b, because we've got the whole bracket being raised to the exponent of 2. So meaning to say that's our a in this case here, and this is our b, just like a plus b squared. So on this, it gives us a squared, which means we are going to have the integral of a squared. If we square this 1 over 2 squared, we get 1 over 4, all right? That's 1 over 2 squared, it's 1 over 4, plus 2ab, meaning to say we are supposed to multiply 2 times a. What is our a? Our a is a half, times our b. What is our b? Our b is a half of cos 3x. So the half and the 2 here cancels, we remain with half cos 3x. So meaning to say this is going to give us plus half cos 3x. All right, half cos 3x. This is from our 2ab. Then we also have plus b squared, meaning to say is the last term squared, b squared. So the last term is this one. We square this. We are squaring 1 over 2 cos of 3x like this. This is the part that we have to square. So we square 1 over 2. It gives us 1 over 4. So that will be 1 over 4. We square the cos. So it is going to be cos squared of 3x like that. All right. So this is how you expand that squared. We just have to go back to our normal a plus b squared. At this stage, as we can see, we can integrate. Everything can be integrated here. We can integrate everything here. So let's integrate. The integral of 1 over 4 with respect to x is going to be 1 over 4. So that will be 1 over 4x. plus 1 over 2, we integrate cos. Remember, cos changes to a sine. So it's going to be sine 3x, we divide by 3. This was our integration from our N5. Also from our N5, we had the integral of a cos squared and a sine, a cot, whatever that we have. This integral is there also in our formula sheet. All right. So because I did not insert the part that is the one that we need, I'm just going to write it aside. All right. So if you check on your formula sheet on page 3, supposed to be page 3. All right. On page 3, there is an integral which is given under the integrals at the bottom part. There is a cos squared which is given there. If you check that, the integral of that cos squared ax that you're given there with respect to x is given as x over 2, all right, plus sine 2ax, sine 2ax, like this, over 4a. This is what exactly you're given from your formula sheet, 4a plus c. Like I said, I want you to see exactly from the formula sheet on page number 3, at the bottom part, page number 3 of the formula sheet. So meaning to say, whenever I am dealing with a cos squared, I can use that integral because here's a simple substitution. X over 2, so it is going to be x over 2 plus the sine, in this case, we've got the sine of 2ax. So this is going to be the sine of 2ax. Take note, it's 2ax. Our a is this part that is affecting cos, this one, which is this one, ax. But it is now multiplied by 2. So it's 2 times our ax, which is 3x. So if we multiply 2 times 3x, we get what? 6x. So this will be sine 6x instead. Over what? 4a, which is 4 times a. Our a is the coefficient of x, which is a is 3. So it's going to be 4 times 3. All right, so that's how we integrate this at our constant of integration. So that's it. We just needed the formula on this part. Then at this stage, we can be able to simplify whatever that we have, 1 over 4x. All right, so this will be 1 over 4x plus multiply the numerator to the numerator, 1 times sine 3x. This will be sine of 3x over 2 times 3, which is going to give us a 6. All right, plus 1 over 4 times 1 over 2, it gives us 1 over 8. So it will be 1 over 8x. All right, plus, since the plus and the plus, you multiply. So you're going to multiply numerator to the numerator, 1 times sine 6x. It is going to give us sine 6x over, you multiply the denominators together, that is 4 times 3, all right? So if you multiply 4 times 4, that is 16, and 16 times 3, which is 48. So this is going to give us a 48, or just use the calculator at once. Most of us, we are tempted to leave our answer at this stage. This is wrong because we still have a part that can be simplified together here. There is x here, there is x here, 1 over 4 and 1 over 8x. So these are like terms, so they can be combined together. So this is going to be 1 over 4 plus 1 over 8, which is 3 over 8. So you're going to get 3 over 8 on your calculator. So that's 3 over 8x plus the rest you write as it is. So this will be the sine of 3x, everything over 6, all right? So that's the sine of 3x, everything over 6, plus we write as it is again, the sine of 6x, everything over what? Everything over 48, plus the constant of integration. We are done. So there's nothing that you can do further. That is how we can present our answer at the end. So as you can see, it was just a direct integral of our trigonometry, where you need to know the exponent that you are working with. You are working with an even exponent. So the way you expand also for a cos and a sine is different on how you expand a cot and a tan. So you have to be very careful on those expansions. All right. The number 2.5, which is the last part of our question here, it is given to integrate. This is x tan x. All right. Let us just have this 2.5. The integral of x tan of x like this plus the ln of sec x. So this is ln sec x. This is a single term like this. All right, so you're supposed to integrate this whole part with respect to x. All right, so let us just open a bracket and see what is it going to be helpful. All right, so let's think along the lines here. All right. Like I said, let us think along the lines. Here, there is a product of two terms, meaning to say we are supposed to think of by parts. All right? We are supposed to think of what? By parts. Then here we've got a ln sec. Can we integrate a ln sec? We have to think of an opposite of that. And that is the opposite is there from, I'm going to explain that one. All right. This one I'm going to explain. But the first part is from our by parts. So what you need is we are supposed to integrate this separately and this one separately. All right. So let's start with these two here, the product of two terms. It's an algebraic and a trigonometric. These ones, they can't work any magic to be simplified. They are different terms. Algebraic trig. So you think of the by parts. So here we are supposed to think of applying by what? By parts. But here we are just gonna apply our direct integration here. This one is a direct integration. It's there in our formula sheet. I'm going to show you how to take it from the formula sheet. Okay, so meaning to say on this one by parts, remember your formula, by parts formula, the integral of f of x by g prime x dx is equal to f of x. So you're gonna have the product of f of x and gx minus the integral of f prime x gx dx. Remember your formula. All right. So there's a need for us to have our f of x. So our f of x, we can take our f of x to be x, and our algebraic is going to be easier that way. All right, so let us just do this. Okay. So I'm just going to choose my f of x to be x. All right. For an algebraic and a trig, I said it's best for you to choose algebraic. Okay. So f of x is equal to x. So if f of x is equal to x, what will be the derivative? Because we need the first derivative on our by parts formula. So the first derivative of x is 1. Okay, we move on to tan. So the tan is the remaining part of g prime x dx that is remaining. That is your tan. So meaning to say the remaining part, which is g prime x dx. All right, dx, this one is the one representing what? Our tan, in this case. All right. But with respect to what, this dx is there, remember. So it's going to be tan x dx. So it's going to be tan x dx. Tan x dx. Okay. Tan x dx like this. So to find gx, integrate both sides. This will be gx is equal to the integral of a tan. How do you integrate a tan? All right, on your formula sheet on page number 2, I want you to get to page number 2 so that we move together. On page number 2, you see that the integral of a tan ax on the far end of that is under the integral. The integral of a tan ax dx is equal to 1 over a. All right, then it's given as the ln sec of ax. So it's the ln sec of ax like this, plus the constant of integration. That's how we integrate. But here, we are not worried about the constant of integration since we are not done with our integral. So it means if we integrate tan, this is our x is a 1, guys. So it was supposed to be 1 over 1. Ln of sec, this 1 over 1 is just like that. So this is just going to be ln sec. So it is going to be ln sec ax, which is sec what? Which is sec x like this. All right. That is what we are going to have in this case. This is our gx. Okay. Now with this gx, I want us to be very, very careful. Okay, no problem. You understand me. Let us get back this to the formula, because we know that from our by parts, we are supposed to get this and substitute into the formula. And this is what we have here. Like I said, the by parts is operated or is taking control on the first part of this x tan x, this one, with respect to x. So we are supposed to apply this by parts as, so this is going to be equal to f of x by gx. Our f of x, which is x times gx, which is ln. So this is ln of sec x. This is our gx, which is ln of sec x, like this. All right. Minus, all right, the integral of f prime x, which is the first derivative of f of x, which is 1. So this is 1 times gx dx, which is our gx, which is the ln of sec x. So this is the ln of sec x, like this. With respect to x, we're going to integrate this with respect to x. All right. And on this other end, this is on the by parts of this one. What about this one? If you check, guys, this is plus ln sec x. And this is what we have here, plus a ln, it's under the integral, just like the same part. So it's like this, the integral of ln sec x, which is the same ln sec x that we, so guys, it's the same thing that we have. So instead of you integrating this, you come back, you integrate this. It's like we've got x plus x. You integrate this x, you get a 1. I mean, you integrate this x here, you get x squared over 2. You integrate this x, you get x squared over 2. Then you combine this, then at the end you get an x squared. So why is it that we could have just added this together? We get our 2x. Then if we integrate, it's going to be 2x squared over 2. This 2 and 2 cancels, you get your x squared, which is the same answer like that. So it is the same thing. Instead of you integrating this separately and the other one separately, just integrate, just combine them. All right. Instead of combining them, they cancel it, in fact, because, yeah, guys, am I with you? I'm alone. You see, Maths N6, guys, it's so interesting because you learn, even as a teacher also, you learn from that. All right. I want us to see something. If we are to combine this, are you seeing that this is minus 1 ln sec x plus 1 ln sec? So what is going to happen? This will cancel here. This whole thing here will cancel. Minus 1 plus 1, that's a 0. This whole thing is the same. So you see now, if you are someone who has integrated, you have integrated. After the long process of integration, it cancels later. Then you say, now I have wasted my time. So as you can see, guys, this whole thing here is canceling because they are the same. All right. So meaning to say, we are going to remain with the x ln sec x. So this will be ln sec x. This is the only part that is going to remain here. Whatever that you're going to do, even if you were to integrate, it was going to cancel. So that is plus the cost of integration. We are done. Okay. Just for the sake of revision, someone is asking, what if it was that we are supposed to integrate? What were we supposed to do? Okay. This is what we are supposed to do. I want you to see here. We said the derivative and integration are simply a reverse. So you check where there is a ln, if there is a ln sec that we actually differentiated before. Okay. That we differentiated before. Do we have a condition that you can differentiate? You get a ln of something. All right. On our derivatives, we do not have that. All right, so it was going to be difficult. So that's why this question was like this. They wanted you to simplify this way. So here it did not need any direct integration, no. So the direct integration is not there here. We do not have. All right, but for any other integral, guys, let me know if there is any other way that you think you could have integrated that way on the other part, because yes, it was going to be difficult, very, very difficult. But at this stage, as you can see, these two are going to cancel, so it's done. That's how it was supposed to be integrated. All right, so that was it, 18 marks on everything. So I challenge you guys, I challenge you to work as much questions as you can. This is the challenge that I'm giving you. Work as much questions as you can. Join membership family for unlimited access of these classes, working with question papers, working with topics, introduction of topics. So make sure that you join the membership which is for our N6. If you want to join the membership of N6, it must be the third level of our membership platform, of which the third level is the Gigantic approach. In order for you to have unlimited videos for N6, you join Gigantic approach. There is basic, there is medium, there is Gigantic like this. This one is for N6. All right. So you join this one, you have unlimited access to your classes for your N6, like for mathematics N6 and other subjects to come for N6. But I think that's it. So more to come from Maison African Motives till we meet again.